The air is cool with salt and wet stone, and below the dark cliffs the mud still shines from the tide that has only just gone out. You are standing on the Bay of Fundy shore in that brief, quiet interval when the sea has stepped back and left its work exposed. Red sandstone, darker basalt, rounded stones, weed dark ledges, all of it lies open under the pale morning light. From here, the cliffs do not look finished. Their faces are cracked, notched, and undercut, as if the water has been reading them line by line for a very long time. Twice each day, the bay gathers itself and returns, lifted by the pull of the moon and shaped by this narrowing basin into one of the highest tides on earth. What seems solid from a distance begins, at the shoreline, to show its softer layers, its hidden seams, and the places where water always finds a way in. For a few hours, you can walk outward across the exposed floor and see the base of the cliffs where the real shaping happens. And if you linger there a little longer, the whole coastline begins to explain itself in stone, sediment, and the quiet return of the tide. At first, the shore feels wider than it should. The waterline is so far out that the bay seems to be holding its breath. A little stream, which would be invisible at high water, now threads across the mud in a silver line. It bends around rounded stones and disappears into a shallow channel cut by the last retreating tide. That channel is the first clear sign that this place is not simply uncovered when the sea leaves. It is actively arranged. The withdrawing water has sorted the ground into bands and textures. Smooth flats of silt, ridges of rippled sand, strips of gravel, mats of dark weed left shining on the rock. Each surface tells you how the water moved only an hour ago. Where the current slowed, the finer particles settled. Where it quickened, lighter sand was lifted and pushed onward. Where it struck stone, it curled, scoured, and left a narrow trench at the cliff base. That trench is shallow here, no more than a dark line beneath the red wall. But once you notice it, the whole cliff changes. It no longer appears to rise from solid ground. It appears to stand on a margin that is being quietly removed. You begin to walk toward it, because distance had hidden the lower story. From farther back, the cliffs looked firm, almost architectural, with a dark cap of basalt resting above the warmer red stone. Up close, the contact between those layers is less neat. The basalt is broken into blocks and columns. The sandstone beneath it is bedded, crumbly in places, harder in others. Streaked by old seepage and marked with pale veins, loose fragments already lie below, scattered over the ledges like the first sentences of an unfinished explanation. The choice becomes simple. You can stay on the open mud and watch the cliff from a safe distance of morning light, or you can follow the receding margin and read the rock more closely before the tide turns. So you keep going, slowly, toward the place where water presses hardest twice each day. As you near the base, the air changes. It smells more strongly of iron, clay, kelp, and cold stone. Thin films of water still trickle from the cliff face, following tiny paths through the sediment. Those trickles are small, but they matter. They tell you that erosion here does not belong to the tide alone. Rain enters from above. Groundwater seeps outward. Winter frost opens spaces that water can return to later. Then the tide rises again and uses every weakness it finds. A shelf of sandstone ahead has been worn into a shallow overhang. The roof of it is stained darker where moisture lingers. Its lower edge is smooth in a way the upper cliff is not. That smoothness is evidence of repetition. Water carrying suspended sand has touched this same band again and again, polishing as it removes. Just beyond it, a chunk of fallen rock rests half buried in silt. Its broken face is brighter than the cliff behind it. The break is recent enough that the red still looks fresh, so the process is not hidden in geological abstraction. It is happening now, on a scale your eyes can hold. You stop there for a moment because one fallen block explains more than the full height above it. This is what the cliff becomes when support is taken away. First a crack, then a sag, then a fall, and afterward the slow reduction into smaller stone. Around the block, the tide has already begun the next stage. Pebbles gather on its upstream side, where currents lose energy. On the other side, a small scoured hollow has formed where flow accelerates around the obstacle. Even after falling, the stone keeps shaping the shore. You look up again, and the structure of the cliff becomes easier to read. The red layers were once sediment, laid down grain by grain in a very different world. Some beds are thicker, some finer, some cut by pebbly bands that resist erosion a little longer. The basalt above arrived later, dark and dense, the remains of lava spread across much older surfaces. Now both are being worked by the same tide, but not at the same rate. That difference is why the cliff does not weather evenly. The softer red rock yields first, the harder cap can linger. And because the lower part is removed more quickly, ledges and alcoves begin to form. From below, that imbalance gives the coast its unfinished look. A seam in the sandstone runs almost level with your shoulder. Along that seam, the rock has opened into a narrow groove. The groove is too regular to ignore. Water found a bedding plane there, entered, widened it, and returned to it over and over. A few meters farther on, the same line deepens into a recess where seaweed still hangs wet and black. It is not a cave yet, but it is becoming one. The evidence gathers in small details rather than grand gestures. There are tiny pockets weathered into the wall like thumbprints. There are rust-colored streaks where iron minerals have oxidized after meeting air and fresh seep water. There are shells fixed to lower surfaces, marking how high the sea commonly reaches. There are stones at your feet that match precise layers above, as if the cliff has begun shedding copies of itself. Because each detail points in the same direction, the larger conclusion arrives quietly. The cliff is not one thing. It is a stack of materials, each with its own strength, its own way of breaking, its own pace of surrender. And the tide is not striking an even wall. It is selecting. It presses most strongly at the base, enters the weakest zones first, and gradually turns difference into shape. Farther along the shore, the ground changes underfoot. The soft mud gives way to a rougher platform of stone and compacted sediment. Here the last tide left shallow pools trapped in depressions. They are still and clear. In one pool, strands of rockweed lie like dark ribbons. In another, a scatter of tiny snails clings to the wet edge. The pools are calm, but they are part of the same mechanism. Each one holds water against the rock after the sea retreats. Each one extends dampness, salt, and chemical weathering into the hours between floods. Even stillness participates. A line of rounded cobbles has been gathered into a low ridge near the cliff foot. They are smoother than the fragments fresh from the wall. That means they have already traveled, rolled, and struck one another through many tides. The bay is not only cutting cliffs down, it is carrying their remains through stages. Wall to block, block to boulder, boulder to cobble, cobble to pebble, pebble to sand, and finer still, the shore under the cliff is not separate from the cliff. It is the cliff, only later. Out across the broad floor of the bay, the exposed channels curve toward the deeper basin. You can see where they rejoin, where water will return first. That matters, because this immense rise and fall is not caused by some local quirk of weather. It is tied to the shape of the bay itself. Fundy narrows inland. Its long basin responds to the pull of the moon and the rhythm of the Atlantic in a way that amplifies the tidal range. The incoming water is guided, focused, and lifted. The result is not a single dramatic wave, but a patient mass of sea returning over hours, filling every channel, wrapping every ledge, climbing every notch in the stone. That repeating flood gives ordinary erosion extraordinary persistence. A coast that might elsewhere be touched by modest tides is here reworked with unusual reach. The high and low margins are far apart, so a broad band of cliff and shore sits inside the daily machinery of change. You kneel near the base of a darker wall where basalt has broken into angular pieces. The contrast with the sandstone is immediate. The basalt feels denser, colder, less willing to crumble. But it is not immune. Vertical cracks divided into rough columns and blocks. Where those joints widen, frost, and water can pry them apart. Below, fragments gather in a darker talus, so hardness does not mean permanence. It only changes the style of failure. The sandstone softens, flakes, and slumps more readily. The basalt fractures and drops in heavier pieces. Together they create a cliff with two tempos layered in one face. This is where the coast begins to tell a deeper story. The red rock belongs to a time long before the modern bay, when sediments were spread across lowlands, channels, and dry floodplains in an ancient rift setting. The dark rock records another interval, lava crossing those older surfaces when the crust was being stretched and broken. What stands before you now is the meeting point of those older events and the present tide. The bay did not create the rock, it inherited it. Then it began to read whatever had already been written there. A small alcove ahead draws your attention, because the roof of it carries two different colors. The lower curve is red and damp. Above that, a darker overhang projects slightly outward. The shape makes the process clear. The softer unit below has been removed faster, leaving the harder unit above to jut outward. But overhangs are temporary forms. Once enough support is lost, the projecting mass will crack and come down. What looks stable this morning is really a stage between one arrangement and the next. That realization changes how you walk. You move more slowly now, not out of fear, but out of attentiveness. Fresh debris lies in thin fans below certain sections and not others. Some faces are streaked with active seepage. Some ledges are sharply cut, others are softened by repeated wetting and drying. The cliff is full of signals. To read them is to understand that erosion is distributed unevenly in both space and time. One notch deepens faster than another. One block loosens over several winters. One layer resists until the beds beneath it are gone. A little farther on, you find a section where the wall has weathered into small hollows, close packed and irregular, as if the surface had been lightly pecked away. Salt, moisture, and differences in cement between grains can produce this kind of texture. The result is a honeycombed skin over a larger mass. Tiny features, but they matter because they increase surface area. More surface means more places for water to linger, crystals to grow, grains to loosen. The cliff roughens itself into further vulnerability. The shore here begins to narrow. On one side, the wall rises sheer and layered. On the other, a shallow incoming thread of water is already moving through the lowest channel. The turn of the tide has not fully announced itself, but the first consequence is visible. The exposed floor is no longer simply exposed. It is beginning to be claimed again from its lowest points upward. You pause and look outward. The bay still appears broad and open, yet the channels have darkened. Water is collecting in them. A few minutes ago they looked like etched lines in mud. Now they look connected. Because of that change, you have another choice to make. You could continue farther along the narrowing base and gain a closer look at a sea-cut notch ahead, or you could stop here, where retreat inland will remain easy as the water returns. You choose to stop and watch. That decision feels true to the place. This coastline explains itself best when nothing is hurried. From where you stand, the incoming water first reaches the stones rather than the cliff. It threads quietly between cobbles and around the edges of stranded weed. Then it spreads, thin as glass, over flatter rock. The movement is almost too gentle to notice until a floating ribbon of algae lifts free and turns. That single motion reveals the larger one. The bay is coming back, and because it returns over such a wide floor, the transformation begins as a series of small connections. One pool overflows into another. A channel links with a trough. An island of mud becomes a peninsula, then disappears. The route you walked out on starts to simplify as boundaries blur. The science behind it remains calm, but it is immense. The tide here is magnified by timing and shape. The natural pulse of water entering and leaving this long basin aligns closely with the rhythm forced by the moon and the open ocean. That near resonance allows each incoming tide to build higher than it otherwise would. Then the narrowing geometry of the bay concentrates the water farther inland. The result is not magic and not violence. It is repetition made powerful by fit. You can hear that fit now in the smallest sounds. Pebbles click softly as the first stronger wash nudges them. Water enters the undercut line at the cliff base and darkens it. A narrow fall of sand slips from one damp seam and leaves a faint streak below. Nothing dramatic happens, and yet the whole landscape has begun to change shape by the minute. The same notch that looked dry and harmless earlier is now a receiving point. The same Foreman block that sat stranded in silt is becoming an obstacle around which currents divide. The same ledges that held still pools are losing their stillness. As the water deepens by inches, the logic of the shore becomes easier to see. Every contour directs flow. Every fracture gives entry. Every difference in hardness becomes an influence on form. It is impossible now to treat the tide as background. It is the main architect if you stand long enough. Even one morning is enough to understand why. The cliff above is written in deep time, yes, but the hand that keeps revising it is present and punctual. The sea does not need surprise to reshape this place. It only needs return, and as the first broader sheet of water reaches fully across the ledge in front of you, the attention naturally settles lower, toward the precise band where each tide presses hardest against the foot of the cliff. There, the cliff is easiest to read. The upper wall can still look massive and settled, but the lower band carries the marks of constant contact. It is darker where the water lingers. It is smoother where suspended sand has passed over it again and again. And it is more broken where joints, bedding planes, and softer seams give the tide a place to begin. If you follow that narrow band with your eyes, from one end of the cove to the other, a pattern starts to appear. Some sections stand out slightly, protected by harder layers. Other sections retreat into shallow recesses. The line is irregular, almost conversational, as though the sea has been asking the same question of every part of the cliff, and each kind of rock has answered in its own way. What seems, from a distance, like a single wall, is actually a meeting of many differences. The red sandstone does not erode evenly because it was never deposited evenly. Some beds were laid down by slower water, with finer grains and more mud. Some came from stronger flow, carrying coarser sand and small pebbles. Some were cemented more firmly after burial. Some remained looser, more willing to soften when moisture returns, so the tide arrives at a surface already filled with variation. And variation gives erosion something to work with. A thin seam that yields just a little faster can become a groove. A groove can hold water longer after the tide falls. Held moisture can weaken grain bonds, encourage salt growth, and leave the rock more vulnerable when the next flood reaches it. Then the groove deepens, the wall above loses support by a small amount. A ledge begins, almost invisibly. The process is so gentle in any single hour that it can seem motionless. But the forms around you are the proof that stillness here is only slow movement. You can see it in a recess not much deeper than your hand. You can see it in a shelf beneath a harder bed. You can see it in a slumped pile of debris where the cliff has already stepped back a little from its former line. The darker basalt changes the pattern, but it does not stop it. Basalt cools into joints, and those joints matter. They divide what might look like one heavy mass into separate blocks. Water enters those fractures from above, especially where rain and fog keep the surface damp. In winter, freezing can widen them. At the base, tidal washing clears away loosened fragments. So even the stronger cap rock is not one solid shield. It is a series of pieces waiting on their own particular schedule. Where the sandstone below is removed first, the basalt may remain as an overhang for a time. That overhang gives the cliffs some of their distinctive shape. It can cast a small shadow at low tide. It can shelter a strip of wall beneath it from direct rainfall. It can make the cliff seem more secure than it is. But the geometry contains its own future. The farther the lower rock retreats, the less support remains for the heavy layer above. Eventually a crack widens, a joint connects, and the projection comes down in angular blocks. Then the shore receives another temporary rampart of fallen stone. You stand close enough now to notice that some fractures are dry and pale, while others are marked by a thin, dark line. Those darker lines are places where water still seeps. Groundwater is one of the quieter forces here, but it is always at work. Rain falls on the plateau above the cliffs. Some of it runs off quickly. Some sinks into soil and porous layers, then moves slowly through the rock until it meets a less permeable bed. At that boundary, it spreads sideways and emerges on the cliff face. The result can be almost delicate. Just a damp seam, a fine trickle, a patch of persistent moss where conditions allow. Yet over time, that seepage can soften sediment, carry dissolved minerals, and maintain a weakness that the tide later enlarges. So the cliff is worked from both directions at once. From below, the sea cuts and scours. From above and within, water loosens and prepares. The place where those efforts meet is often where change becomes visible. A narrow notch at the base is one expression of that meeting. So is a damp, undercut ledge where grains can be rubbed free by every returning tide. So is a section where blocks seem ready to peel away along a bedding plane that has already begun to open. If you trace one vertical slice of cliff from top to bottom, it starts to feel less like a wall and more like a record. At the top, weathered soil and vegetation soften the edge. Below that, a dark basalt cap appears, fractured into rough columns and blocks. Beneath the basalt, the red sandstone is layered, sometimes in broad bands, sometimes in thinner beds with occasional gravelly lenses that resist a little longer. Near the base, the surface changes again. It becomes more polished in places, more notched, more clearly shaped by the direct sweep of water and the abrasive load it carries. And at the very foot lies the present debris. Fresh fragments, old rounded stones, and mud settling in the quieter pockets between them. It is almost possible to read time from top to bottom. The upper edge speaks of the land's surface now. The basalt remembers a volcanic interval unimaginably older. The sandstone beneath recalls ancient sedimentary plains. The notch at the base belongs to the tides of this moment, and the fragments on the shore belong to the next stage already underway. A single cliff face, then, is not a single event. It is a stack of episodes meeting in one place. A small hollow in the wall holds several barnacles, high above the water that has only just begun to return. Their position marks a habit of flooding. Not every tide reaches exactly the same point. Winds, air pressure, and the lunar cycle make quiet adjustments. But over many returns, the intertidal zone becomes legible. Different organisms gather at different levels. Algae darken some ledges and not others. Shells cling where immersion lasts long enough. Above them, the rock shifts toward drying, salt spray, and seepage rather than full submergence. So the cliff carries not just geological lines but biological ones. Life maps the tide as clearly as erosion does. On a lower ledge, where water is spreading in a thin, clear sheet, the stone has been roughened into tiny pits. Some are no larger than a coin. Others merge into shallow cells. The texture resembles a weathered honeycomb, but softer in expression, less geometric than human-made honeycomb, more like a skin of little recesses. This kind of pitting can form where minerals within the sandstone weather at slightly different rates, or where salt crystals grow as moisture evaporates and push grains apart. The effect is modest, almost decorative at first glance, yet these minute hollows do important work. They increase the amount of edge exposed to water, they trap moisture, they provide miniature starting points for the loosening of more grains. The cliff teaches the same lesson at every scale. Small irregularities invite larger ones. A broader recess farther ahead gives the same lesson in a form easier to see from several steps away. The roof is intact, but the back wall is damp and uneven. Seaweed left by the previous high tide still clings to one side. The floor is strewn with rounded pebbles. When the tide rises, water will funnel into this shallow shelter, circulate there, and then withdraw again, carrying some material out and leaving some behind. A recess like this is not only evidence of early erosion, it is a working shape, active each day. The bay is full of these half-made forms. There are places not yet caves, but moving in that direction. There are overhangs not yet failed, but clearly dependent on material already being removed. There are isolated pillars not yet detached from the mainland, but nearly outlined by weakness on either side. You do not need dramatic change to understand the future. The geometry is already offering it. What is striking is how little haste the process requires. A cliff can spend years, decades, longer still, in one recognizable arrangement, while quiet adjustments continue at its margins. A crack widens by fractions. A notch deepens by small increments. Stormier tides do more in some seasons, freeze and thaw do more in others, but even in still weather, the bay continues its ordinary labor. That is part of what gives this coast its calm feeling. The forces are enormous, yet they are expressed through repetition rather than spectacle. As the water rises, a ledge near your feet disappears under a translucent film, and then under a steady, shallow flow. The details do not vanish all at once. First, the finest textures become harder to see. Then, pebbles lose their sharp edges beneath the surface. Then, the darker seams in the rock take on a glossy sheen. Soon after, reflections begin to replace direct view. The tide edits the shore by degrees. That same gradualness is part of how it shapes the cliffs over longer spans. It does not need to break the wall in one gesture. It only needs to keep altering the conditions at the base, returning again before the rock can ever become fully separate from the sea's influence. A line of cobbles, left in a low arc by the retreating water, starts to tremble as the incoming wash reaches it. One stone shifts, then another. There is a soft clicking sound, then stillness, then another small adjustment. The movement is minor, but it matters. These rounded stones are tools as well as products. They were made from earlier erosion, and now they contribute to later erosion by rubbing, striking, and grinding in the zone where currents move them. In a place with a smaller tidal range, such work might be concentrated in a narrower strip. Here, the vertical reach of the tide broadens the active band. That broadness is one reason Fundy's cliffs feel so continuously engaged with the sea. The bay is not merely touching the shoreline, it is traveling up and down a considerable height, using different water levels to work different parts of the coast. At one stage, water may be concentrated near the low platform, stirring pebbles and sand. At another, it reaches the undercut sandstone seam. Higher still, it bathes ledges where algae can grow and moisture can persist. During the greatest tides, it can climb far enough to refresh the upper biological markers of the intertidal zone. This repeated vertical sweep creates a wide corridor of wear, wetness, chemistry, and ecological opportunity. Standing here, you can feel that wide corridor as a set of overlapping influences rather than a single line. There is the present edge of the water, glossy and moving. Above it, the damp band from the previous tide. Above that, barnacles and stains that suggest the ordinary upper reach. Above them, drier red rock where direct tidal contact is less common, though salt spray and seepage still matter. The cliff is zoned, but softly. Nothing is sharply divided. The transitions blur, as natural boundaries often do. A narrow fracture descends through the sandstone in front of you, almost straight at first, then wandering slightly as it reaches a softer bed. At the base, the fracture has opened just enough to cast a thin shadow. Water entering there will not remove a whole block today or tomorrow, perhaps not for many years. But the opening allows several things at once. It admits moisture, it increases surface area, it gives freezing water room to expand in colder seasons. It creates a plane of weakness the tide can exploit once the surrounding rock is lowered. That is how so much of Fundy's cliff erosion works, not by a single dominating mechanism, but by many cooperating ones. Mechanical wear, chemical alteration, groundwater seepage, thermal and seasonal changes, gravity and the daily tide all overlap. The cliff responds to the combined effect. That is why cause and effect here can feel both immediate and long delayed. A winter frost may widen a crack, but the visible fall may come in late summer. Heavy rain may saturate a layer from above, but collapse may wait until undercutting removes enough support from below. A basalt block may remain apparently secure long after the sandstone beneath has retreated, then settle all at once into the accumulated space. Nothing in the visible moment tells the whole story, and yet each moment leaves evidence. A fresh angular fragment at the base tells you a joint has recently given way. A fan of damp sand below a seam tells you grains are still being released. A protruding ledge tells you differential erosion is in progress. A sea-cut notch tells you the tide has concentrated its effort there for a long time. The shore is patient with explanation. It repeats the lesson in every cove. Farther down the line of cliffs, the red sandstone rises in broad bands beneath a dark cap that looks almost level from this angle. That apparent levelness is part of the volcanic story inherited from deep time. Lava spread over older sediments, cooling into a more resistant layer. Later, erosion exposed the contrast. Now, because the lower sandstone usually yields faster, the basalt often appears as a protective roof. But protection in geology is usually temporary, conditional, and local. The cap can shield the rock directly beneath it from rainfall for a while. It can delay retreat in one place. Yet once support is sufficiently reduced, it becomes a burden rather than a shelter. Its weight contributes to failure. So the very contrast that gives the cliff its visual beauty also gives it structural tension. Red below, dark above, two histories, two resistances, one shared future at the shoreline. The incoming tide has now reached the foot of the fresh fallen block you noticed earlier. A few minutes ago, mud and pebbles lay exposed around it. Now water curls around its upstream side, slows in the quiet pocket behind it, and spins little eddies where its irregular shape redirects the flow. Even detached stone keeps participating in the arrangement of currents and sediment. Given enough tides, the block will be reduced. Edges will break down. Smaller pieces will collect. Rounded forms will emerge where repeated contact removes corners. Material from this one fall will be spread over a broader area. Some may become beach gravel. Some may be carried farther into channels. The cliff is always sending out pieces of itself, and the bay is always deciding where those pieces will rest next. That outward journey begins the moment a fragment touches the shore. Yet not all fallen material leaves quickly. Sometimes talus at the cliff foot acts as a temporary buffer. A pile of blocks can absorb wave and current energy that would otherwise strike the wall directly. For a while then, collapse can create its own partial defense. But in Fundy, with such persistent tidal exchange, that defense is rarely permanent. Finer material is washed out sooner. Smaller stones are transported more readily. Larger blocks are undercut, shifted, or broken over time. The buttress slowly disappears. Then the exposed cliff behind it becomes vulnerable again. This alternating pattern, erosion, collapse, temporary protection, renewed erosion, helps explain why the coast can change in steps rather than at a perfectly even rate. If you looked at the same headland over generations, you might not see a smooth retreat. You might see pauses, then renewed recession. You might see a buttressed base one decade, a clearer notch the next, a collapse after that, and then a fresh pile of debris beginning the sequence again. The coast withdraws, but not like a ruler sliding backward. It withdraws in rough increments. That roughness is part of the cliff's character, and it is part of why the shore often appears unfinished. You shift your attention upward again, to a narrow line of vegetation near the cliff top. Roots there have their own small role. Plants can stabilize loose soil in some places, but roots also enter joints and bedding planes, widening them as they grow. Water follows those roots. Organic matter changes the chemistry of the near-surface zone. What begins as a thin vegetated edge can contribute, over time, to a line of weakness beneath it. This does not mean the cliff top is quietly prying itself open everywhere. Only that life and rock are not separate stories. They meet in the fine details. Lichens on drier faces help retain tiny amounts of moisture. Algae darken the lower wall where regular flooding allows them to thrive. Burrowing organisms in the mud at the foot of the cliff can loosen sediment that tides later move away. The shaping of a coastline is rarely just one agent acting alone. Even where stone seems to dominate, living processes enter the margins. Below a small seep, the sandstone has become darker and softer looking, as if rubbed with a wet cloth. If you were to touch it, grains might come away more easily there than from the drier surface beside it. That local weakening matters. Tide after tide, the difference in firmness can become a difference in shape. The weak patch recesses first. A tiny overhang forms above it. Moisture is then retained more efficiently in the sheltered pocket. The contrast grows. A small defect becomes a visible hollow. This is how many coastal forms begin, not with grandeur, but with a slight imbalance that repetition turns into something larger. The Bay of Fundy is full of such imbalances. Its tidal range is the largest on Earth not because the ocean here behaves by a different set of physical laws, but because ordinary laws happen to align in an unusual way. The basin is long and narrowing. The natural sloshing period of water in that basin happens to be close to the timing of the incoming Atlantic tide. That near match allows energy to build rather than cancel. As the water is funneled inland, the range increases. The upper bay receives the amplified result. So the cliffs before you owe their present condition partly to a kind of fit between form and rhythm. The bay's shape and the moon's pull do not argue. They reinforce one another. And because they have been doing so over immense stretches of time, the coastline bears their conversation in stone. The thought is large, but the evidence remains wonderfully local. A notch at ankle height, a pebbly lens standing out from a softer red bed, an overhang that has outlasted the support beneath it only provisionally. A tide pool, lingering in a depression just long enough to keep a patch of rock wet through the morning. Everything broad in geology seems to arrive through details like these. As the returning water creeps higher, some of the lower clues become inaccessible. The small pits blur, the exact outline of the notch disappears under reflection. Only the larger recesses remain obvious. This feels appropriate, because the sea is always concealing part of its own work. Low tide offers a temporary reading. High tide closes the book part way and leaves the shaping to continue unseen. That alternation between exposure and concealment is part of the rhythm of understanding this place. You learn a little, then the water takes the lower pages away. On a section of wall where sandstone gives way upward to basalt, the transition is marked by a ledge of broken fragments. Some are red and rounded. Some are dark and angular. Their different shapes tell you something about their origins and their resistance. Sandstone fragments tend to wear down more readily, becoming smoother under repeated movement. Basalt can retain sharper edges longer, breaking into blockier pieces along its joints. Mixed together at the cliff foot, they create a kind of field sample of the entire wall above. If you stayed here long enough and watched each tide move among them, you would see how sorting begins. The smaller, lighter, or more rounded pieces are easier to shift. The larger and more angular ones remain longer, at least until enough energy or enough undercutting changes their position. Sediment transport, then, is not random wandering. It follows grain size, shape, density, current speed, local slope, and the roughness of the bed. What the cliff loses, the bay organizes. That is true of the very finest material as well. When sandstone and mudstone layers soften and release clay and silt, those tiny particles can remain suspended in the water, making the bay appear brown or opaque during stronger movement. Later, where currents slow, some of that suspended load settles. In the quieter corners of coves, that fine material can settle into thin skins of mud, so smooth that the morning light seems to rest on them rather than reflect. Those skins will not stay untouched for long. The next tide will wrinkle them, streams will score them, and small creatures beneath will turn them from below. But for a little while, they preserve the bay's gentler side, the part of erosion that does not strike or grind, but simply drifts and settles. That matters, because the Bay of Fundy is not only a place of removal, it is also a place of sorting, laying down, gathering, and beginning again. The cliffs are shaped not only by what is taken from them, but by what remains nearby long enough to alter the next tide's path. A shelf of mud can redirect a shallow current. A bank of gravel can shield one patch of shore and expose another. A fresh fan of fallen stone can briefly soften the sea's reach at the base of a wall. Then, in time, those new forms are adjusted as well. The bay does not keep any arrangement for long. It keeps only the process. And because that process repeats with such unusual range, even the familiar terms of shoreline geology feel broader here. A beach is not simply a line of sand. A mudflat is not simply a level plain. A cliff is not simply a boundary between land and water. Each one expands and contracts with the tide until the landscape seems to have more than one version of itself. At low tide, the base of the cliff becomes a place you can approach, inspect, and understand. At high tide, the same base disappears into moving brown water, and the wall rises directly from the sea. Neither version is false. Both are true. The shape of Fundy is a shape in motion. That is easiest to appreciate when you stop walking and let your eyes adjust to change rather than distance. The incoming water has now covered most of the lower ledges. Only the upper surfaces of larger stones remain dry. A few minutes more, and they too begin to darken. What had been a scattered arrangement of pools is becoming one connected sheet. What had been many little separations is becoming a single surface with hidden relief beneath. In that merging, the coastline recovers its high tide simplicity. But if you have watched the return carefully, simplicity no longer means stillness. You know what lies below the water now. You know there are grooves and pits and notches under that rising sheen. You know there are seams of weaker rock receiving the flow. You know there are fresh fragments already beginning their slower journey into cobbles and sand. So even as the sea conceals the detail remains present in your mind. That is one of the quiet pleasures of this place. Low tide teaches you how to see high tide. And once you have learned that, the bay begins to feel less like a surface and more like a moving cross-section. A darker line of water enters from the outer channel and slides inward along the shore. It carries suspended sediment, fine enough to stay aloft in the flow. Near one small projection of rock, the current curls, slows, and leaves a faint cloudy border where some of that load begins to settle. Just a subtle change in speed is enough to reorganize the material. This is the same principle working at larger scales throughout the bay. Where currents accelerate, they can lift and keep particles moving. Where they slow, they release them. So the shape of the shore does not only result from erosion, it also determines deposition. A cliff creates a fallen block. The block redirects water. Redirected water causes sediment to gather in one place and scour in another. That new arrangement changes how the next tides arrive. The coast is constantly responding to the consequences of its own previous change. Once you begin noticing this, the shoreline becomes less like a fixed edge and more like a conversation between stone and moving water. The conversation is old, but it is not repetitive in a dull way. The same general motions return, yet each return meets a slightly altered shore. A ledge has thinned, a notch has deepened, a block has fallen. A mudflat has shifted its shallow channels. A marsh creek further inland has widened or filled a little. The tide does not arrive at an untouched stage. It arrives at the result of everything it did before. That is why the cliffs are best understood as temporary forms. Not temporary in the sense of fragile or fleeting within a single day, but temporary in the deeper geological sense. They are stages. They stand for a while in one arrangement, then in another. Their apparent permanence is really just slowness scaled beyond ordinary attention. The return of the tide helps correct that illusion. As the water rises, the notch at the base of one sandstone wall becomes a thin shadow beneath the surface. Then the shadow vanishes. A little later, the lower edge of the wall itself loses definition. Water and stone blend into one reflective plane, and the cliff seems to stand more cleanly than before. It almost looks restored. but the restoration is visual only. The hidden erosion continues under the surface, exactly where your eyes can no longer follow it. That hiddenness is part of why sea cliffs often seem more durable than they are. Their most active zone is frequently covered. Only at low tide do they reveal the band of attack. Only after a fall do they reveal how much preparation had already taken place out of sight. So the bay moves between explanation and secrecy. It shows you enough to understand, then covers the evidence again. This rhythm of revelation is especially clear in places where the shoreline bends inward. A shallow cove near you has already become a small basin. The water there deepens faster than on the flatter ledges beside it. The reason is simple. The floor is lower, the contours guide flow inward, and the incoming tide always reoccupies its old pathways first. That reoccupation tells you something important about the relation between short-term and long-term change. The tide does not move randomly across the shore, it follows topography, and much of that topography was created by earlier tides. Channels formed by repeated drainage are filled first on the return. Undercut sections receive focused flow because they already recess. An isolated block becomes a divider of currents because collapse placed it there. The present movement always inherits the past shape. This is as true for the bay as a whole as it is for the little cove at your feet. Long before this particular tide rose over today's ledges, the larger basin had already determined how water would behave here. The Bay of Fundy is broad at its mouth and narrows towards its head. That narrowing matters at every stage of the tide's inland journey. As water is pushed in from the Atlantic, the shape of the basin constrains where that water can go. It rises, it spreads over broad tidal flats. It deepens in channels. It presses against cliffs that are exposed for hours and then submerged again. All of this is intensified by the fit between the bay's natural oscillation and the incoming ocean tide. The result is not merely a high tide, it is an amplified system of regular flooding and draining that has had immense time to work. If the cliffs were made of perfectly uniform, resistant rock, the shoreline would still change under such conditions, but they are not uniform. They are layered, fractured, and inherited from an older geological world. That inherited complexity gives the tide something to select among. And selection is one of the essential ideas here. Water does not need to defeat the whole cliff at once. It only needs to find the weaker grain, the softer seam, the open joint, the undersupported layer. It needs to deepen the little difference until the difference becomes form. That is what you have been seeing all morning. Now, as the sea climbs higher, another realization begins to settle in. The cliffs belong to a very long story, but the story did not begin with the bay. The notch at the base is modern in geological terms. The repeated flooding is ongoing, the present shape of the coastline is active and unfinished. But the rock itself, the red beds and dark cap, arrive from much older circumstances. And once you start thinking in that direction, the cliff face changes again. It becomes not only a shoreline, but an exposed archive. The red sandstone at the base of these cliffs was not formed beside this modern tide. It began as loose sediment in a world with very different geography. The grains were carried by rivers, spread across dry flood plains, dropped in channels, laid down in shifting beds of sand and mud. The reddish color comes largely from iron minerals that oxidized in open air, which often suggests deposition in well-drained terrestrial conditions. So when you look at the warm red bands in the cliff, you are not looking at old seafloor in the ordinary sense. You are looking at a land surface made stone, a record of ancient rivers and exposed plains. That alone gives the bay a strange depth. The modern tide cuts into rocks that remember dry ground, and above those sediments lies the darker memory of fire. The basalt capping many Fundy cliffs comes from lava flows associated with the stretching and breaking of the crust when the supercontinent Pangaea began to come apart. This did not happen quickly. It unfolded over vast intervals, with faulting, subsidence, sediment accumulation, and volcanic activity all participating in the making of the basin. The present coast, is one visible edge of that ancient rearrangement. What now feels quiet and settled was once part of a rifting landscape, where the crust opened, low areas formed, and sediments collected in those developing basins. Later, lava spread across some of those deposits, cooled, fractured, and became the resistant dark layers you see overhead. So the cliff face is not merely a wall of rock, it is a stack of environments. River sediments below, volcanic rock above, marine erosion in the present. That is why a single walk at low tide can feel so layered in time. Your feet stand on a shore shaped by today's tide. Your eyes rest on sandstone laid down by ancient streams. Above that, your gaze reaches basalt from a volcanic chapter tied to continental separation. Then the modern bay returns and works at all of it together. This meeting of times is one reason the Bay of Fundy feels both intimate and immense. The details are close enough to touch. The meaning stretches backward, almost beyond imagination. A pebble near your boot may have weathered out of a sediment bed first deposited in the Triassic period. A dark, angular fragment nearby may have broken from lava that cooled when the Atlantic world was only beginning to open. Neither fragment announces its age. They simply lie together in the tide's reach, equal under the same wash of brown water. The bay has a way of bringing deep time down to the scale of a hand-sized stone. That does not make the past smaller. It makes the present more textured. You begin to see why the cliff looks the way it does. The sandstone's bedding reflects old cycles of deposition. Some layers mark stronger currents in ancient channels. Some mark quieter overbank settling. Some contain coarser grains and small pebbles that tell of more energetic flow. Others are finer, softer, more vulnerable to weathering now that they stand exposed in a marine setting. Then the basalt arrives in the story as a harder interruption. It did not emerge grain by grain. It spread as molten rock, then cooled into dense dark masses prone to jointing. Its resistance is greater, but not absolute. Its fracture pattern is different. So the modern profile of the cliffs depends heavily on this ancient contrast. Where sandstone retreats, basalt may overhang. Where joints in basalt align with support lost below, blocks break free. Where sandstone includes a coarser lens, that lens may stand out briefly before the surrounding finer material is stripped away. Everything visible now is partly inherited from the conditions of deposition and cooling long ago. Erosion reveals old structure. It does not invent it from nothing. If you imagine the cliff in cross-section, the story becomes clearer still. Start with a low basin formed as crust stretched and faults dropped blocks of land downward. Rivers enter that basin carrying sand, silt, and gravel from surrounding highlands. Season after season, flood after flood, those sediments build up. Mud cracks under dry intervals. New channels cut across older deposits. Pebbles are left in bars. Finer silts settle in calmer spaces. Then, later, lava pours across parts of the landscape, burying earlier surfaces, cooling into broad sheets, and hardening into basalt. Over incomprehensible spans of time, burial, compaction, and cementation turn the sediments into sandstone and mudstone. The lava becomes solid caprock. Much later, uplift, faulting, and erosion expose this layered record once again. And still later, the modern Bay of Fundy shapes the coast we are standing beside. In that long sequence, the tide is the most recent sculptor, but not the only author. The cliff is the place where old authorship and new shaping meet. That is an important distinction. Without the ancient rift basin, there would be no red sedimentary stack here. Without the volcanic chapter, there would be no dark cap to create those dramatic overhangs. Without the present tidal regime, the coast would not be carved in quite this way. The landscape exists because different times contributed different things. Deep time built the materials. The tide arranges the present form. A gull passes far above the waterline, then disappears beyond the headland. The sound it leaves behind fades quickly, and the cliffs return to their quieter language of seepage, water, and stone. This hush suits the shift in scale. It lets you think backward without feeling rushed. You can look at the red beds and imagine a dry plain beneath an older sky. You can picture braided streams carrying sediment through a rift valley where the future Atlantic had not yet fully emerged. You can imagine the lava spreading dark and fluid across those surfaces, sealing one chapter beneath another. Then, just as gently, your attention returns to the present ledge, where brown water is now lapping against a notch. The coolness of the current, the smell of iron and salt, the wet shine on the sandstone, all of it reminds you that deep time is not abstract here. It is exposed. And because it is exposed, the bay can keep editing it. Some beaches feel made mostly of the present. A sandbar shifts after a season of storms. A dune moves with the wind. A marsh edge creeps inland or outward over years. Fundy has those kinds of short-term changes too, but its cliffs also show something more durable and more ancient. Their instability operates on inherited architecture. The wall fails where old bedding planes, joints and contrasts in rock strength make failure possible. So even a fresh collapse often begins in structures created tens of millions of years ago. The present event is local, its preconditions are ancient. This is what makes geology so calm once you settle into it. Cause and effect unfold across many scales at once. A trickle of groundwater today follows a layer laid down in a vanished river system. A winter freeze in a basalt joint exploits a cooling fracture from an old lava flow. A collapsing ledge falls because the tide has been removing support from a sandstone seam, whose softness reflects sediment deposited under particular conditions long before the bay existed. Nothing happens in isolation. Everything arrives with a history. That history includes continental change on a scale difficult to hold in one thought. When Pangaea began to break apart, the crust in this region stretched. As it stretched, faults developed. Some blocks subsided and created basins where thick sediments could accumulate. This was not a single neat tear, but a prolonged phase of extension, volcanism, and basin development across what is now eastern North America and neighboring regions. The rocks around the Bay of Fundy belong to that broader story. Their local beauty is part of a planetary rearrangement, yet even that vast frame returns you, in the end, to humble details. A pebble band in the sandstone is the trace of flowing water. A mud-rich interval suggests quieter deposition. A basalt ledge marks a lava surface now arrested into stone. Geology often works this way. The largest stories can only be read through the smallest reliable evidence. You walk a little farther inland now because the incoming water has narrowed the available shore. From this slightly higher position, the cliffs are easier to take in as a whole. The dark basalt cap becomes more continuous from one headland to the next. The red beds below it step out in varied thicknesses. Here and there, vertical fractures divide the wall into sections that look almost like giant books tilted toward the sea. The image is tempting because these cliffs do feel readable. Not quickly, not completely, but patiently. Each bed is a page of conditions. Each fracture is an opportunity for later weathering. Each overhang is an argument between resistance and support. The bay reads those pages differently than rain alone would. On an inland escarpment, the same rock might weather into slopes, gullies, and blocky outcrops shaped mostly by runoff, freeze-thaw, and gravity. Here, the addition of immense tidal range changes the emphasis. The lower wall is repeatedly flooded. Sediment is removed and redistributed more efficiently. A wider vertical zone stays active. The cliff foot remains central to the process, so even though the rocks come from ancient continental rifting, their present expression owes much to marine repetition. This blend of origins and influences gives Fundy a distinctive calm complexity. The cliffs are not monumental in a blank static sense. They are full of explanation. And because the explanation is visible, the place feels generous. You do not have to guess that different rocks weather differently. You can see it. You do not have to imagine that the tide is altering the base. You can follow the notches and alcoves. You do not have to take deep time on trust alone. The red sedimentary stack and dark volcanic cap are there in front of you, side by side. The shoreline is doing something rare and kind. It is teaching without hurry. The higher the tide rises, the more the lower details disappear. And this also seems fitting. The oldest structures remain visible longest. The broad layering persists after the small pits and grooves have gone under. The ancient story outlasts the morning's close inspection. Perhaps that is why these cliffs feel so balanced. They allow both scales at once. You can notice the grain loosening in a damp seam. You can also remember the breaking apart of Pangaea. Neither cancels the other. The bay holds them together. Farther out, where the exposed flats were broad earlier, the surface is now largely water again. Only the higher bars and stones still show. Channels that looked carved into mud have become the dominant pathways of flow. Their curves are clearer now because the water follows them with reflective precision. This return of the channels invites your attention back to the tide itself. The rock's inherited structure explains why the cliffs fail in certain ways, but the tide explains why the bay can act so continuously over such a wide active margin with such transforming regularity. If the ancient story gave the coast its materials, the next story to understand is the pulse that cannot help returning. By now, the shift is unmistakable. Places you stood not long ago are underwater. The little recesses at the cliff foot are full. The first isolated stones have become low, dark humps in a broadening surface. Still, there is nothing abrupt in the transformation. Fundy does not need abruptness. Its scale is large enough that simple persistence feels almost ceremonial. The incoming tide advances with the assurance of something that has done this too many times to require drama. It fills the lowest spaces first because they are lower. It reaches farther inland because the basin narrows. It rises high because the timing between the bay's natural rhythm and the ocean's forcing allows the water to build. The science is exact. The experience is strangely tender. You are watching a landscape recover one of its regular forms. Earlier, the bay seemed emptied, almost improbably withdrawn. Now it seems to remember itself. That memory is physical. The water follows the basin's shape. It enters old channels. It wraps around familiar projections of shore. It slips around the stranded blocks you studied at low tide and turns them, once again, into underwater shapes. The change is easiest to see at the edges first. A narrow runnel that had looked carved into wet clay becomes a reflective ribbon. A shallow basin that held separate pools becomes one smooth sheet. The small bars of gravel between them soften, then vanish as water climbs over their backs. What had been a broad floor begins to act like a basin again. That transformation is one of the quiet signatures of Fundy. In many coastal places, the tide redraws the shore by a modest amount. Here, it remakes the relationship between land and sea on a much larger scale. A place that seemed inland an hour ago returns to being seabed. A ledge that seemed fixed and approachable becomes a submerged shelf. The cliff, which had looked grounded in open air, begins to rise directly from water again. The effect is so complete that it can feel as if there are two coasts here, taking turns. Yet, they are not separate worlds. They are two phases of one repeating system. And that system depends on timing as much as on shape. If you imagine the bay as a long, narrowing vessel connected to the Atlantic, the motion becomes easier to picture. Water enters from the wider mouth and is pushed landward by the ocean tide. But because the basin has its own natural period of oscillation, a kind of preferred sloshing rhythm, the incoming tide does not simply pass through unchanged. It meets a basin already inclined to move on a similar schedule. That near match allows the water to build higher than it otherwise would. Not perfectly, not mechanically, but enough to matter immensely. This is the idea of resonance, though here it feels less like a laboratory word and more like a habit of the landscape. The bay receives the ocean's pulse, and because its dimensions are well suited to that pulse, it answers strongly. Then the narrowing inland geometry concentrates the volume farther toward the head of the bay. So the tremendous rise and fall is not caused by one feature alone. It is the result of fit layered upon fit. Lunar gravity supplies the great rhythm. The Atlantic carries that rhythm toward the coast. Fundy's basin responds in near sympathy. Its narrowing shape lifts the result higher, and because this arrangement repeats day after day, the cliffs experience not a rare event, but a constant condition. That distinction matters. A storm can be powerful, but it is occasional. The tide is powerful here in a quieter way, because it is ordinary. Its energy returns whether anyone is watching or not. It enters the same coves, touches the same notches, surrounds the same fallen blocks, and reaches for the same ledges with patient regularity. The shore is shaped less by surprise than by certainty. As the water rises past the lower stones, the channels you noticed earlier become more active. One fills first, then carries a dark current inward along the cliff base. Another remains shallower for a few minutes longer, then joins the first in a low, swirling confluence over the mud. These small sequences repeat the logic of the whole bay. Depressions fill first, routes already cut by past movement become preferred pathways again. Relief controls flow, and flow in turn modifies relief. A channel exists because water favored it. Water favors it because it exists. This kind of feedback is everywhere in tidal landscapes. Here, because the range is so great, the evidence is unusually easy to watch in a single sitting. A little rise in the bed can hold back water for a short time. Then the level increases just enough, and that low barrier is overtopped. Suddenly, two separate pools become one connected surface. That new connection changes the current pattern downstream. Sediment begins settling in one corner and scouring from another. The effect may be tiny, but enough tiny effects, repeated through countless tides, become visible landforms. You can hear some of this change as much as see it. Pebbles answer the current with faint clicking sounds. A ribbon of water entering a narrow notch makes a soft, hollow note under the cliff. Seaweed lifted from the rock gives a slick whisper as it turns in the flow. Above those sounds there is a larger quiet. The bay is not loud in the way people often imagine moving water to be. It is more measured than that. Its scale is vast, but its return often feels deliberate. The force is spread through time. That spread is part of what allows the incoming tide to act as such an effective architect. It is not merely arriving, it is occupying. It reaches into spaces, fills them, deepens them, and changes how every next minute will unfold. A low stack of rock farther along the shore had looked like a grounded pillar at low tide. Now the water has reached its base. A little later it circles the stone completely. What had been attached by a strip of mud is cut off. This is one of the bay's simplest and most instructive reveals. A feature does not need to move in order to change category. The tide changes the meaning of place. A stack becomes an island again. A passage becomes a channel. A shelf becomes a submarine platform. An accessible cave mouth becomes a dark opening half hidden above moving water. The cliff face itself changes character under this reoccupation. Dry textures begin to disappear. The lower bands darken until distinctions of grain and small weathering pits are harder to see. Reflections slide over the wall. A place that seemed legible at low tide becomes partly secret again. But this concealment is not a loss. It is part of how the bay works. Exposure teaches you where the weakness lies. Submergence reminds you that the work continues even when hidden. At a distance, the incoming tide can look almost passive. That illusion lasts only until you focus on one object and return your attention to it a few minutes later. A stone that stood clear is now awash. A notch that lay open is now glossed over by brown water. A patch of mud that held bird tracks is now featureless and smooth. The water need not rush for the effect to be profound. A broad, steady rise is enough. In that way, the tide resembles many geological processes. The pace is calm, the consequences are not small. You glance outward again toward the middle distance of the bay, and the broad water now has a faintly different surface. Earlier, with the tide far out, the basin looked emptied and exposed. Now the reflective field is returning, carrying streaks of suspended silt and darker paths where deeper channels guide the incoming flow. The surface itself becomes a map of hidden topography. Where water runs fast over a channel, it can appear smoother and darker. Where it spreads thinly over shallower ground, it may wrinkle in the wind or show a lighter, muddier tone. These patterns are subtle, but once seen, they change how the bay feels. It is no longer a simple rising sheet. It is a moving body reading the basin from below. This is also where the scale of water moved through Fundy becomes easier to respect. The rise at some parts of the bay can reach extraordinary heights, but even more striking than height alone is the volume involved. Each tide shifts immense quantities of water into and out of the basin. That mass carries suspended sediment, reworks channels, floods marshes, and presses against cliffs over a vertical range far larger than in most places. So when you think of the coast being shaped by the tide, it helps to think not of a line creeping up the shore, but of a whole basin breathing. The cliffs respond to that breathing at their feet. The mudflats respond across their wide surfaces. Creeks, pools, stacks, ledges, and boulder fans all respond in their own ways. No part of the margin is entirely outside the rhythm. The lunar part of the story remains wonderfully simple. The moon's gravity helps raise tides across the world. The sun contributes too, though less strongly. When moon, sun, and earth align more closely, spring tides are higher. When they are at right angles, neap tides are lower. Fundy follows these familiar cycles, but its local geometry turns familiar causes into uncommon results. That means the cliffs are not worked identically every day. Some tides climb farther than others, some reach ledges usually left dry, some flood the upper intertidal communities more completely, some leave more time for surfaces to drain and dry before the next return. This variation matters because erosion is sensitive to level as well as force. A notch that is regularly wetted, but only occasionally fully scoured, will change differently from a lower shelf stirred every day. The bay's extremes, then, are not one fixed number. They breathe within the larger breathing. The shore remembers that in zones, stains, shell lines, and patterns of wear, a higher spring tide can leave weed and driftwood lodged farther up the cliff base. It can wet a seam that remains dry under a smaller tide. It can saturate pockets where salt later crystallizes as the rock dries. Those effects may look minor when they happen, but repeated through seasons and years, they widen the active field of change. The coast is not carved by one idealized average tide. It is carved by a whole family of tides, all related, all slightly different. There is a gentleness in that idea too. The bay is consistent, but not monotonous. Its rhythm repeats without becoming exact. That slight variation is one reason living things can inhabit its margins so richly. And as the water presses high against the rock, attention naturally begins to drift from stone alone to the life arranged around this flooding and uncovering. For now, the evidence of that life gathers in little bands. Dark rockweed, draped on lower ledges, lifts and sways as if remembering the sea it never really left. Barnacles fixed to the sandstone hold their places between immersion and air. Periwinkles cling above the immediate wash, waiting in their own measured stillness. These creatures do not resist the tide in the way a wall might resist weather. They belong to it. Their timing, feeding, and drying all depend on the same rise that is undercutting the cliff behind them. At low tide, the pools beneath the wall looked still and separate. Now those pools are filled, connected, and becoming part of the larger intertidal band again. Life in them shifts accordingly. Small crustaceans hidden among weed can drift loose and resettle. Tiny snails move onto freshly wetted surfaces. Filter feeders on the lower rock enter the flow and begin to use what the tide brings. Even the brown cloudiness of Fundy's water is part of this living margin. Suspended sediment can make the bay seem opaque from above, but within it are nutrients, organic particles, and the material basis of rich food webs. The tide does not merely move water, it moves meals. It delivers dissolved oxygen, plankton, detritus, and fine organic matter across broad flats and up against hard shore. Then, when it retreats, it exposes feeding grounds of another kind. Mudflats left open for a few hours can support worms, mollusks, and tiny invertebrates in such abundance that birds time migrations to meet them. So the same process that cuts notches in rock also feeds wings, roots, and shells. This is important because the Bay of Fundy cliffs can seem, at first, like a story about geology only. They are red stone and dark basalt. They are undercuts, seep lines, fallen blocks, and tidal amplification. But if you stay long enough, the living edges begin to come into focus. A little green at the cliff top, a black fringe of weed lower down, a line of marsh grass farther inland where the slope eases, a scatter of shorebirds probing exposed flats when the sea withdraws. The coast is not only being worn away, it is being continually turned into habitat. A crack in the rock can become a place where seeds lodge. A seep on the wall can support moss and damp-loving films. A collapsed apron of blocks can create crevices that hold moisture and shade. A tide pool can shelter algae, snails, and larval life between floodings. Erosion is also arrangement. By now, the water has reached nearly to the usual high biological band on the lower cliff. The barnacles are submerged. The weed is fully afloat. Only the upper stains and drier lichen surfaces remain above the gloss of the tide. The scene that looked exposed and skeletal earlier now appears softened and joined. And because the water has removed the clear boundary between cliff and shore, the living margin feels more continuous. Inland from the rock wall, where the bay broadens into mudflat and salt marsh country, this continuity is even more striking. There, the tide enters branching creeks cut into soft sediment. At low water, those creeks lie in dark, winding grooves. At high water, they fill and spread into the marsh edge. The plants rooted there are shaped by salinity, flooding frequency, and the stability of the sediment beneath them. Salt-tolerant grasses and low marsh plants can endure regular inundation. Higher ground, flooded less often, supports different species. Again, the coast is organized in bands, though not hard bands. Everything grades gently, according to how often the sea arrives. That repeated flooding is not merely an inconvenience life endures. It is often the condition that makes life possible there. Tides bring nutrients, they flush waste, they keep some plants from being outcompeted by less salt-tolerant species, they maintain mudflat surfaces where burrowing organisms can thrive. They create the feast that draws migratory birds to the upper bay in late summer and autumn. When you hear that the Bay of Fundy supports extraordinary numbers of shorebirds, the reason is not mystery. It is mud, timing, and tidal reach. The broad exposed flats allow vast feeding areas. The soft sediment contains dense populations of invertebrates, and the daily flooding renews the system. A bird crossing an ocean does not need drama from a landscape. It needs reliability. Fundy offers that in abundance. If you stood farther inland at low tide, perhaps near the head of a marsh creek on a foggy morning, you would see this rhythm in a quieter register. The water would have retreated, leaving gleaming banks and a narrow channel winding through dark mud. Grass along the creek margins would bow lightly over the edge. Tiny rivulets would drain from the marsh surface into the main thread below. Then, hours later, the tide would move back up the creek, first as a darkening, then as a filling, then as a smooth expansion over the lower platforms. No single instant would need to be dramatic. The meaning would be in the return. That same kind of return is present even here, beneath the cliffs. The living communities simply express it differently. Lower on the rock, barnacles and mussels exploit immersion. Rockweed endures drying and wetting in cycles. Lichens higher up take what salt spray and occasional wetting allow. In pockets where sediment gathers, burrowing creatures loosen and rework the material. Their small tunnels improve drainage and aeration. Their feeding disturbs the fine layers. Their presence, in turn, feeds birds. The margin is not static anywhere, not in stone, not in mud, not in life. There is an elegant cause and effect in all this. The extreme tide enlarges the intertidal zone. A broad intertidal zone offers many surfaces and depths for different organisms. Organisms alter those surfaces slightly as they cling, burrow, root, or retain moisture. Those alterations can then influence erosion and deposition. Roots open joints. Algae keep surfaces wet for longer. Burrowers destabilize patches of mud. Marsh plants trap fine sediment and encourage the building of low platforms. Then the next tide arrives and works on a shore already modified by life. The result is not a competition between geology and biology. It is a partnership of small effects within a larger rhythm. Even the color of the coast reflects this partnership. The red of the sandstone belongs to ancient oxidation. The dark cap of basalt belongs to volcanic inheritance. But lower down, green browns and olive blacks from algae and weed soften the mineral palette. Higher up, pale lichens stipple drier faces. On the flats, the mud can take on silver, brown, or blue-gray tones depending on moisture and light. The bay does not keep one color for long. The tide changes sheen. Cloud changes brightness. Wetness deepens some surfaces and lightens others. This shifting appearance adds to the sense that the cliffs are not only objects, but participants in a cycle. They are always being recolored by exposure, flooding, and growth. A narrow strip of vegetation at the cliff top also deserves a quieter kind of attention. At first glance, it seems detached from the marine story below. Grass, shrubs, perhaps a few low-rooted trees where the edge is stable enough. But water connects it to the shore. Rain enters the soil there. Some of it is taken up by roots and returned to the air. Some runs off. Some infiltrates downward and moves through porous layers until a less permeable bed diverts it sideways. Then it appears as a seep on the cliff face. So the vegetation above participates in the cliff's weathering, whether it means to or not. Roots can stabilize the uppermost soil for a time, delaying small slides. They can also wedge into fractures and widen them. Where plant cover is thick, it may reduce direct raindrop impact on the surface. Where roots die back or soil thins, fresh pathways for water can open. The upper edge, like the lower one, is a zone of exchange. Below, the exchange is with the tide. Above, it is with weather, drainage, and growth. The cliff stands between them. Because of that position, it is never shaped by one influence at a time. Imagine a season of late summer fog rolling in over the bay. Moisture condenses on the cool cliff face. Ledges remain damp for longer than they would under clear, dry air. Algae and lichens hold that moisture on some surfaces. At the same time, the tide continues its ordinary rise and fall, wetting the lower wall and refreshing the intertidal belt. Then autumn storms arrive with heavier rains. Winter follows, bringing freeze-thaw cycles into open joints and seep lines. Spring snowmelt feeds groundwater from above. The cliff records all of this, not separately, but together. A fresh fracture in March may owe something to a wet autumn, a cold winter, and years of undercutting before either. That is why even a living margin can feel geologically patient. Changes are distributed through time. Their evidence only sometimes gathers into a visible event. Meanwhile, the ecosystems make use of every stage. A newly fallen slab may create shaded wet spaces beneath it. A fresh mud apron may become burrowable ground. A newly undercut overhang may provide a temporary niche for weed and shell attachment in its splash zone. Then, as the form changes again, those opportunities move elsewhere. Habitat in Fundy is often temporary, but that does not make it fragile in the larger sense. It is repeatedly renewed. The tide builds continuity out of constant rearrangement. This is especially clear on the mudflats beyond the cliffs. To an unhurried eye, a mudflat can appear empty, but that emptiness is often just openness. Beneath the surface are worms, tiny crustaceans, mollusks, and microbial communities, all working in darkness and saturated sediment. When the tide is out, birds arrive to read the flat with their bills and feet. They know where to probe because the mud itself tells a story. Softness, moisture, Density. Recent flooding. At high tide, those flats disappear beneath moving brown water, and the birds shift elsewhere. The food remains. The stage changes. This great alternation of stage and concealment is one of Fundy's governing patterns. It applies to cliffs, it applies to pools, it applies to marshes, and to feeding grounds. The coast is always there, but never in only one form. A late-season flock of sandpipers on the upper bay can make this truth visible without any spectacle at all. They gather over the flats as the tide retreats. They move as if the flat itself were giving them instructions, turning together, settling, then running a few quick steps across the shining mud. Their bodies are small against the width of the bay, yet their timing is exact. They arrive because the retreating water has uncovered food at the right moment, and because the bay uncovers so much of it. What looks, from a distance, like a smooth and empty plain is filled with hidden life. Mudworms, small crustaceans, mollusks, and countless tiny organisms live within the saturated sediment. The extreme tidal range does not strip the flats of richness. It helps renew it. Each flood brings suspended material and nutrients. Each retreat exposes the surface long enough for feeding. Then the water returns and begins the cycle again. The same reach that cuts into cliff bases also lays out this broad table of soft ground. That is one of Fundy's quietest revelations. The force that removes is also the force that provides. Along the cliff foot, that balance is harder to notice at first. A fresh fall of stone looks like loss. An undercut ledge looks like subtraction. But each change creates new surfaces. A newly exposed face of sandstone is raw and bright for a while, open to moisture, colonization, and breakdown. A pile of fallen blocks creates crevices, shade, and hollows where water can linger. A shallow notch can become a pool. A shelf can hold weed. A slump of fine sediment can make a temporary platform for burrowing life. Erosion does not only erase, it keeps reworking the margin into forms that other processes and other living things can use. You can trace this connection with something as modest as rockweed. It grips the lower ledges in dense bands where flooding is regular enough to sustain it, but not so deep that light is lost. When the tide is out, it lies heavy and dark across the stone. When the tide returns, it lifts and sways in the current. That movement slows water slightly near the surface of the rock. It catches drifting fragments. It shelters tiny animals. And when the weed dries, then wets again, it helps hold moisture against the stone beneath it for longer. So even a simple fringe of algae has consequences. It belongs to the ecosystem. It also belongs to the shaping of the coast. Barnacles do something similar in a different way. They build stony coverings on the lower wall and ledges, attaching themselves where immersion is frequent. Their presence roughens the surface. It creates minute turbulence when water flows past. It gives tiny sheltered spaces between shells. No single barnacle changes the cliff, but the living skin they form is one of the many fine textures through which the tide meets the rock. The same is true on the flats, where the work of burrowers matters more than you might guess from their invisibility. A worm passing through mud leaves a tiny tunnel. Many worms passing through the same flat, day after day, season after season, rework the sediment from below. They mix fine layers. They alter how water drains. They help move organic matter downward and bring mineral grains upward. This process, often called bioturbation by geologists and ecologists, is simply life stirring the ground. On a Fundy mudflat, that stirring contributes to softness, oxygenation, and food availability. The birds above depend on it. The surface patterns visible at low tide depend on it too. So when a shorebird probes the mud, it is really following a chain of events that begins with tides, sediment supply, and the hidden labor of very small creatures. You do not need to stand in the upper bay during migration to feel this truth. Even here, near the cliffs, the edge between geology and ecology is blurred in useful ways. A trickle of fresh water emerging from a seep can create a slightly less salty patch on the wall. That shift may allow a narrow band of moss or darker microbial film to persist. A collapsed block can shelter a cool pocket where stranded water remains a little longer than the surrounding ledge. A joint widened by roots and frost can become a perch for seeds, then a line of small plants. Later, those roots open the joint farther. Then the tide reaches the loosened material at the base and takes it away. At every stage, the cliff is a shared place. Stone, water, salt, mud, and life all use it differently, but all use the same forms. Mist often deepens this sense of connection. Late summer fog on the Bay of Fundy can move in quietly and reduce the distance between sea and land. The far side of the basin fades. Headlands soften. The dark basalt cap above the red cliffs seems to hover in pale air. Moisture condenses on every exposed surface. Rock darkens, lichens brighten slightly. The lower weed line glistens. In that kind of weather, the coast seems less divided into parts. Mudflat, cliff, marsh, and water all share one fine skin of dampness. And that dampness is not only beautiful. It matters to weathering. It keeps some surfaces wet for longer. It helps salt remain in pores. It supports films of life that can modify rock chemistry grain by grain. Again, the largest forms depend on countless small conditions. If you shift your attention back to the top of the cliff, you can see another quiet relationship. The land above is not stable in a simple, permanent way. Rain falls there, soils develop there, plants root there, water enters there. All of that affects what happens lower down. A grassy edge can slow runoff. A bare patch can let more water reach the brink quickly. A root can hold one small wedge of soil while widening a fracture beside it. During wet seasons, the upper ground can become heavier with stored water. That added weight matters where cracks already run inward from the cliff edge. The bay's tides may do the visible carving at the foot, but weather and gravity prepare the upper part for its own responses, so the cliff is not just being cut from below. It is also being conditioned from above. That conditioning can be very slow. A slight sag at the cliff top may precede any obvious fall by years. A shallow crack may widen one wet winter, then seem unchanged through several summers. A band of seepage may migrate along a bedding plane as small internal routes open and close. Then, eventually, the signs align. Support has been removed below. Moisture has weakened a layer within. A joint has lengthened through repeated freezing and thawing. The weight above shifts just enough, and part of the wall settles into its next form. Before that later stage arrives, though, it helps to linger in this living margin a little longer, because it changes the meaning of erosion. Without life, a cliff retreat might seem only subtractive. With life included, each retreat becomes more like rearrangement. One ledge disappears, another appears, a pool fills with sediment, then another pool forms where a block has detached. A marsh edge is cut back in one season, then extends slightly where trapped silt accumulates in another. The tidal world keeps offering fresh surfaces and taking old ones away. Nothing living here can demand permanence. What it gets instead is repeated opportunity. That may be why the bay feels so calm even while it changes. The changes are built into the place. They are not interruptions. They are the normal condition. Shorebirds know this by timing. Rockweed knows it by flexibility. Barnacles know it by sealing themselves against air and opening again underwater. Marsh grasses know it by tolerating salt and flooding. Even the microbial life in mud knows it by thriving in a world where oxygen, moisture, and exposure rise and fall on schedule. The cliffs, too, know it in their own unthinking way. They do not resist change successfully or unsuccessfully. They simply pass through it. One part of the wall lasts a little longer because its grains are more tightly cemented. Another part retreats because a seam remains damp and weak. A basalt block stays suspended until enough support is gone. Then it joins the shore below. The landscape feels patient because everything within it is adjusted to process rather than fixity. You can watch this patience in a single tide pool if you stay close enough. At low water, the pool was isolated, ringed with weed and tiny shells. As the tide rose, the pool connected to a narrow channel. Then the channel widened into a sheet. Now the pool has become impossible to distinguish from the broader flooded ledge. Its separate identity is gone, but only for a while. When the water retreats again, it will emerge in much the same depression, though never exactly the same. A little sand may have entered, a few pebbles may have shifted, some weed may have torn free. The outline will be familiar and altered all at once. That is the shape of the entire bay, only on a different scale. Every part of the margin is familiar and altered. This matters because the next phase of the cliff story depends on accepting that change is usually prepared in silence. A collapse, when it finally becomes visible, can seem like an event, but the real work happens long before the moment of movement. It happens in damp seams, in widening joints, in frost-shattered cracks, in undercut notches, in the slow removal of support from below, and the slow accumulation of strain above. The living margin you have been watching does not sit outside that process. Roots enter cracks. Moisture lingers under weed. Burrowing creatures loosen sediment at the foot of the wall. Marsh edges shift, where fine material is trapped or taken away. Everything contributes a little. Then gravity takes what has been prepared. The clue is often there well in advance. A ledge projecting too far, a fracture darkened by seepage, a slight bulge beneath the cliff top where materials are beginning to creep, a fresh scatter of angular fragments below one zone while neighboring sections remain quiet. If you walk this coast often enough, you begin to notice these signals, not with anxiety, more with the same kind of attention you would give to weather or tide height. The cliff is always becoming something. Sometimes that becoming is too small to see from day to day. Sometimes it gathers into a brighter, fresh scar on the wall and a new pile of stone below. If you imagine one Fundy headland through several seasons, the sequence becomes easier to hold. Begin with late summer, when fog wets the surfaces and seepage keeps one bedding plane dark. The sandstone beneath the basalt cap has already been undercut by many tides. The overhang is modest, but real. At its base, pebbles and suspended sand continue to abrade the lower wall whenever currents are focused there. Above, rain enters the soil at the cliff edge, and some of that water finds joints in the basalt. The season passes, autumn storms bring heavier runoff. The seep line darkens more often. Tiny grains loosen from the damp sandstone seam and gather below as a faint apron. At first, this means almost nothing to an ordinary glance. The wall still looks essentially the same. Then, winter arrives. Water in open fractures freezes on cold nights and expands. In sandstone, repeated freezing can pry grains and thin slabs apart where spaces already exist. In basalt, joints can widen by almost invisible increments. Thaw follows. Then, another freeze. Not every winter does equal work, but the cumulative effect matters. By early spring, snow melt and rain feed groundwater from above. The cliff face begins to weep again along old roots. One narrow crack near the top of the sandstone broadens enough to cast a shadow where none was obvious before. Below it, the notch at the tidal contact zone is a little deeper than last year. Nothing has fallen yet. This is the long moment before the later, clearer change. Now imagine standing there in a calm part of summer. The tide is low, the shore is open. A fresh pattern of seepage stains the wall. A little more debris than usual lies at the base. Some fragments are still sharp-edged, still brighter than the surrounding stone. The overhang does not announce danger. It simply looks more developed than before. Its underside is smoothed by repeated wetting and abrasion. The seam behind it is darker. The support beneath it has receded. A geologist, or anyone who has spent time reading coastlines, would recognize the arrangement. The cliff is approaching another adjustment. Still, even now, the exact timing is uncertain. That uncertainty is part of natural weathering. Preparation can last years. Release may happen in an hour, no one witnesses, or in several smaller steps. A few blocks may settle first, lightening the load above, A skin of sandstone may peel away, then a larger slab may follow later. The coast does not always fail in neat, single pieces. Sometimes it lets go in rough installments. Suppose, though, that in this case the conditions align. Undercutting has taken enough from the base. The bedding plane, weakened by seepage, extends far enough inward. The overlying basalt, already divided by joints, presses down on a sandstone support that has become too thin. Perhaps after sustained rain, perhaps after a winter has opened the fractures a little more, perhaps simply because the necessary amount of retreat has finally been reached. A section of the ledge settles, not explosively in your imagination, but heavily. The sound would be brief compared with the length of preparation. When it is done, the wall has a new shape. The first thing visible afterward is often color. Fresh rock is brighter. The red sandstone, newly exposed, may appear warm and almost raw beside the darkened, weathered face around it. If basalt has come down as well, its fractured surfaces look sharper and cleaner than the older blocks at the foot of the cliff. A new angular pile lies below. Old pathways along the shore are altered or blocked. A notch that once sat in shadow is partly filled with debris. The coastline has changed, not in theory, but in a form your feet would notice. This is the moment many people think of when they think of cliff erosion. Yet the more interesting part is what follows. The fallen material does not remain an ending. It becomes the next stage of shore shaping. Large blocks rest where they fell at first. They can act as a temporary buttress, absorbing some of the energy that would otherwise strike the base of the fresh scar behind them. Smaller fragments gather around them. Mud settles in the quieter pockets between. At high tide, water begins to circle and divide around the new obstruction. Eddies form. Sand and pebbles collect on one side, scour from another. The geometry of the flow changes immediately. So does the pace of future erosion. For a while, the fresh talus can slow direct attack on the cliff. This is one reason coastal retreat often happens in steps. A wall is undercut. It fails. The fallen debris shields the base temporarily. Then the sea and tides work on that debris. Fines are removed. Smaller stones are transported. Large blocks are undermined or broken down by impact and weathering. Gradually the shield is reduced. The cliff foot is exposed again. Undercutting resumes more effectively. Another cycle begins. Seen over decades, a Fundy cliff does not withdraw like a perfectly smooth line. It retreats in rough episodes, with pauses, partial defenses, and renewed cutting. That roughness is written into the shore. You can see old episodes and boulder fans below some walls. You can see recently bright scars above others. You can see overhangs in one cove and fresh rubble in the next, as though different stages of the same process had been arranged side by side for study. And in a sense, they have. The bay is full of examples. Each cove presents a slightly different combination of rock type, fracture pattern, groundwater, tidal focus, and exposure. Some fail by slumping in softer sediment-rich layers. Some fail by toppling blocks. Some produce broad talus aprons. Some generate narrow fans that are quickly reworked. But the underlying logic remains the same. Support is removed, weakness is widened, gravity takes over. The coast is redrawn. Even above the obvious falls, there are quieter forms of downward movement. On gentler sections, where the cliff edge grades into a steeper slope rather than a sheer wall, saturated sediment can creep. Small amounts of material move downslope after rains. Vegetation tilts. Tiny terraces or cracks appear near the top. These are not collapses in the dramatic sense. They are the upper cliff, participating in the same larger tendency toward retreat. Where the lower margin is cut away by the tide, the slope above slowly adjusts. In this way, tidal erosion and subaerial weathering remain linked. The bay cuts the foot. The land above seeks a new balance. That balance is never final. A fresh scar tells the story plainly. Imagine the red face after a slab has come away. The remaining wall may show the bedding planes more clearly than before. A pebbly lens that was once hidden now juts out. A damp seam, formerly internal, is newly exposed and begins its own weathering from the moment it meets air and salt. The cliff has lost material, but it has also gained new vulnerabilities. Every collapse reveals future starting points. A line of weakness becomes a fresh surface. A former interior becomes the new exterior. That is why collapse is not an interruption of cliff shaping. It is one of its ordinary phases. And when you look down at the debris below, the continuation becomes even clearer. The largest blocks are only temporarily large. Wave action in Fundy may be less important than the tides themselves in many settings, but moving water still jostles and sorts loose stone, especially where currents are concentrated and where storms add extra energy. Freeze-thaw acts on exposed blocks too. Edges chip off, corners are removed. One boulder becomes several smaller ones. Smaller ones become cobbles. Sandstone often yields more quickly in this progression, softening and abrading into finer sediment. Basalt can persist longer as coarser material, though even it is not exempt from fracture and transport. So the fallen apron at the cliff base is not static rubble. It is a temporary workshop in which the cliff is converted into shoreline sediment. That conversion changes the emotional tone of collapse. A fresh fall can feel like a boundary crossed, and it is. A visible section of wall no longer exists in the same form, but geologically, nothing has disappeared. Material has moved from one position and one grain-size pathway into another. Vertical wall has become talus. Talus will become rounded beach stone, sand, and suspended mud. Some of that material will settle nearby. Some will travel farther into channels or onto mudflats. Some very fine particles may remain in circulation for a long time before finding quieter water. The coastline has not lost matter so much as redistributed it. In Fundy, redistribution is one of the bay's central talents. This is why a newly collapsed section can look strangely integrated so soon after it changes. The scar above is sharp and bright, but below, the bay has already begun to make use of what fell. Water runs around the blocks at the next tide. Mud gathers in the lee of them. Seaweed drapes over the lower pieces. Tiny pools form between stones. The geometry of habitat shifts almost at once. What seemed like a simple break is immediately folded back into the wider process. You can follow one imagined slab farther if you like. At first it lies at the cliff foot, angular and intact enough that its parent layer is still obvious. After many tides, its edges begin to soften. Perhaps one end is undermined where water accelerates past. A crack opens where winter frost enters. A corner breaks off and is carried a few meters away. The next year, smaller fragments from that corner are mixed with older pebbles already present on the shore. The original slab remains, but less confidently. Years later, only a cluster of rounded stones remains to suggest its former shape. Eventually, even that memory disperses. A few pebbles settle in a gravel bar. Sand derived from its matrix lies farther along the shore, and the bay keeps sorting those remains according to size, weight, shape, and the quiet geometry of its floor. A fragment that leaves the cliff as one sharp piece may finish its long journey as many different things. Part of it may linger near shore as gravel. Part may be ground to silt and lifted into the brown water. Part may settle in a sheltered hollow beyond the reach of the strongest current. This is how a cliff begins to travel. It does not walk outward in one body. It leaves in stages and fractions in clouds and rounded stones. The red sandstone is especially easy to follow in this way. When it breaks down, it often returns to forms close to what it once was before stone held it together. Grains separate. Finer material loosens. Mud-rich beds dissolve into soft suspensions that the tide can carry for a long time before laying them down again. The basalt takes longer. Its fragments can remain coarse and dark on the shore, resisting rounding for more tides. But even that resistance is only a slower version of participation. Nothing at the cliff foot is exempt from the bay's patient sorting. You can see the first evidence of this outward movement in small places. A narrow pocket beside a fallen block holds fresh red sand that was not there before. A gravel bar farther along the cove has gained a few darker stones from the caprock above. A muddy ribbon in the returning water marks suspended sediment lifted from the base of a recent fall. Each sign is local. Together they describe a wider truth. The Bay of Fundy does not simply take material away from the cliffs and lose it. It redistributes it through the whole tidal system. Some of what leaves the cliff base will settle only a short distance away. In quieter corners where the current slows behind projections of rock or along the inner bend of a channel, sand can gather into thin veneers over older surfaces. In broader, low-energy areas, finer particles may drift down through stiller water and add another almost invisible layer to a mudflat. These additions are small in any single tide, but the bay has had a very long time to repeat itself, and repetition, here, is enough to build landscapes as surely as it can wear them down. That is why the story of the cliffs cannot end at the moment of erosion. The cliff face is only one stage in a larger exchange between land and water. Sediment removed from a red wall may become part of a beach ridge for a while. Later it may be lifted again, carried inland over the flats, and laid down where marsh plants can trap it. Over time, enough fine sediment caught among roots can raise a low marsh surface increment by increment. Then that marsh too becomes part of the bay's unfinished architecture. The coast is not only retreating, it is also being rebuilt in other forms nearby. This exchange is easiest to picture if you imagine the bay at several speeds at once. At the speed of a single tide, water enters, covers, withdraws, and leaves behind rearranged mud, weed, shells, and stones. At the speed of years, channels migrate slightly, bars shift, marsh edges advance in one place and are trimmed back in another. At the speed of generations, cliffs step landward, sea stacks separate, beaches change composition, and entire coves alter their outlines. At the speed of geologic time, the sediments produced by all this erosion may one day be buried, compacted, and turned to stone again. What is falling from the cliff now could become a future rock layer under very different skies. That possibility gives the bay a strange kind of circular calm. Ancient sediment became cliff. Cliff becomes sediment again. The process is not neat and not quick, but it is continuous. A grain of quartz, weathered from sandstone and carried out across a tidal flat, is not at the end of its story. It is simply between forms. The same is true of clay suspended in the muddy water. When currents are strong, those tiny particles remain aloft and travel far. When the water slackens, some settle. Later, they may be stirred up again. Eventually, if enough fine sediment accumulates in a sheltered setting, layer upon layer can build a thicker deposit. Those layers may preserve traces of burrows, plant roots, shells, and the chemistry of the water that laid them down. So even the most ordinary brown cloud in Fundy's tide can be thought of as future memory in motion. You do not need to imagine distant burial to feel this. Even the mud beneath your feet at low tide is a kind of archive. Its smooth surface may carry tracks of birds for an hour. Its shallow drainage lines may record the retreat of the last tide. A little deeper down, it may preserve older bedding, organic matter, and signs of earlier surfaces now covered. Then the next flood comes and writes over part of it. The bay is always recording and always revising. The cliffs participate by supplying new material to the record. On some shores, beaches are built mostly from shells, coral fragments, or river sand brought from inland. Here, beneath the Fundy cliffs, much of the shoreline sediment is unmistakably local. The beach can be read upward. Rounded red pebbles tell of sandstone beds above. Darker, denser stones speak of basalt. Mud at the edge of the cove may contain material softened from weaker layers in the cliff and reworked many times. Even drift patterns on the flat can hint at the source uphill. The shore is a translation of the wall behind it. And because the wall keeps changing, the translation keeps being updated. A fresh collapse can alter not only the immediate cliff line, but the sediment budget of the small bay around it. More coarse debris at first, more fine red material as the softer beds are worn down, a temporary barrier to flow where blocks accumulate, new eddies, new patches of deposition. The consequence spreads outward from the fall. This matters especially where the bay opens into broad mudflats and low marsh edges. Fine sediment delivered from eroding cliffs can contribute to the soft surfaces beyond the rockier shore. Then, when salt marsh plants trap that fine material among stems and roots, the sediment becomes part of a living platform. In this way, cliffs and marshes are linked, even when they seem like different worlds. One provides material, the other catches and organizes part of it. The tide moves between them. There is a quiet generosity in that relationship. A wall of red rock gives itself away grain by grain. Farther inland, a low green margin receives some of that gift and turns it into habitat. Marsh plants slow the water enough for suspended particles to fall out. Their roots bind the accumulating mud. Their stems collect rack and organic matter during higher tides. Over long periods, such trapping can raise the marsh surface, though never beyond the reach of continued change. Then channels cut into it. Banks slump, creeks widen or shift. Nothing stays settled forever. Still, the exchange continues. Where the shore steepens and cliffs dominate, coarse fragments may remain near their source for quite a while. In broader embayments, finer material may travel farther before finding rest. This sorting is not random. Current speed, basin shape, grain size, and the roughness of the seabed all matter. A heavy basalt cobble needs more energy to move than a grain of sand. A grain of sand settles sooner than a clay particle under the same conditions. That is why Fundy's shores often show such distinct textures close together. Gravel ridges here, silty flats there, muddy pools in one recess, cleanly washed cobbles in another. The bay is always choosing where each size can pause. If you stand back from the details, the larger image becomes beautifully simple. The cliffs are not only being cut down, they are being spread out. What was once vertical becomes horizontal. What was once fixed in a wall becomes mobile in water. What was once one layer in the cliff can become many separate deposits in bars, flats, and channels. The bay takes concentrated form and turns it into dispersed form. Then, through settling, trapping, and burial, some of that dispersed form becomes coherent again elsewhere. This is not a cycle you can watch complete in one tide, but you can watch enough of it to understand the direction. Even evening light helps make this visible. As the day lowers, the red sandstone can deepen toward rust and wine. The basalt above darkens toward blue-black. Wet surfaces hold more light than dry ones. Mudflats farther out catch the sky in pale silver. And through this changing light, the relationship between materials becomes clearer. The dark cap still stands above. The red layers still carry the marks of old rivers and floodplains. But below them lies a shoreline made partly of their own remains. The beach is the cliff, only translated into fragments. The mudflat is the cliff only reduced beyond recognition. The bay floor is full of former headlands. Sometimes fog comes in before the light is gone. It moves low over the water and softens every edge. A sea stack that looked sharp at low tide becomes a dim shape in grey air. The line where basalt meets sandstone is muted, though not erased. The highest surfaces hold on longest. Lower forms disappear first into haze and water. This softening suits the bay's unfinishedness. Fundy rarely offers a final, hard outline. Its forms emerge, withdraw, blur, and return. A cliff seen at dawn after low tide is not the same cliff seen at dusk under fog and flood, though the rock has not changed much in a day. Perception changes with the water. That change is part of the landscape itself. Out in the basin, the next tide has already begun long before the shore fully notices. Water deepens elsewhere first. Channels far from you begin to adjust. Then, little by little, the effects arrive here at the cliff base. The same is true of longer futures. A cliff can look settled for years, while small preparations continue beyond easy notice. Sediment can gather in quiet places for a long time before a marsh edge becomes visibly broader. A gravel bar can shift a little each season without seeming to move at all, unless you remember where it lay before. The bay is full of slow thresholds. Nothing announces itself loudly. It simply becomes undeniable after enough repetition. And because the bay is always unfinished, there is no single proper moment to call the process complete. Not for a headland, not for a cove, not for a marsh creek. Each is passing through an arrangement. That arrangement may last longer than a human life or change noticeably within 1 decade. Either way, it belongs to a much longer continuity. The cliff's future is already present in its seep lines, fractures, and undercut base. The sediment's future is present in the calm pockets where currents fade. The marsh's future is present in the fine silt caught among stems at high water. Every form here contains its next version in small hints. That is one reason the Bay of Fundy feels so deeply calm. It does not promise permanence, and so it does not disappoint when forms shift. A block falls, a beach grows coarser, a mudflat silts over a little more, a creek mouth widens, a ledge disappears beneath the returning sea. Nothing is broken from its intended path. Change is the intended path. You can feel that most strongly when dusk begins to lower across the basin. The broad flats, if the tide is out, become a dim reflective plain with channels threading through them like dark silk. If the tide is in, the water rises nearly to the cliff roots and the shoreline simplifies again into wall and sea. Either way, the shaping continues. Even in darkness, seepage still moves through the rock. Even in darkness, suspended clay still settles where currents are slow enough. Even in darkness, marsh grass bends with the flood and releases it again. The bay does some of its most important work unseen. That hiddenness does not make it mysterious in the dramatic sense. It only makes it patient. The highest tides on Earth are often described by numbers, but what matters more here is their habit. They return often enough and range widely enough that every margin must adjust to them. The cliffs are one expression of that adjustment. The mudflats are another, the salt marshes are another still. All are linked by the same movement of water, and all are made from exchange. Land to sediment, sediment to flat. Flat to marsh, marsh to channel bank back to suspended load. The categories blur if you watch long enough. Even the dark line of basalt above the red sandstone carries this lesson. It seems, at first, like the stable part of the view, the anchoring band, the roof over the softer stone. Yet it too is temporary in the face of support lost below, and fractures widened above. Its darkness, its apparent steadiness, are part of the beauty of the cliffs, and part of the tension within them. The more the red beds retreat, the more the basalt must wait on less support. Then one day it joins the shore and enters the same sequence as everything else. Heavy block, broken block, cobble, pebble, sediment. The bay is always inviting the hardest things into softness. If you follow a single cove through enough time, the geometry tells this story quietly. A small notch at the cliff base becomes an alcove. The alcove enlarges. A projecting point is narrowed on both sides and begins to stand out as a pillar. A slab falls from the roof. Debris fills part of the opening. The next tides clear some of it. The cave deepens or collapses. A stack is isolated. Later it is shortened, then reduced again. At no point is there a true ending. There are only stages recognizable from one season or century to the next. This is why the cliffs can feel both grand and unfinished at once. They are not monuments completed in the past. They are ongoing negotiations between inherited rock and recurring water. The negotiations are not even. Some sections yield quickly, some hold a little longer, some are protected for a time by their own fallen debris. Some are opened by groundwater from above, but all remain in the conversation. And because the bay keeps such steady time, the conversation never really stops. Even now, as the light thins, there are practical signs of that continuity all around you. A fresh, brighter patch on one wall where weathered skin has recently given way. A fan of angular fragments below it, not yet rounded enough to lose their origin. a smooth mud pocket beside those fragments, already collecting the finest part of the collapse. A line of weed lodged high on a ledge, showing the reach of the last greater tide. A marsh creek beyond the cove, dark and narrow at low water, wider and glassy when the flood returns. Each detail belongs to one place. Each is also part of the whole bay's design. That design is not planned, of course. It emerges from geometry, gravity, sediment, and time. But emergence can feel almost composed when the same forces have been working together for so long. The funnel shape of the basin amplifies the tide. The tide attacks the cliffs and redistributes their material. The redistributed material settles according to changing current and shelter. Living communities take hold where the rhythm allows them to. Those communities then influence how water, moisture, and sediment behave at the margins. The result is a shoreline that keeps remaking itself without ever becoming unfamiliar. You could come here year after year and still recognize the same headlands. You could also come back and find a ledge gone, a beach altered, a notch larger, a marsh edge slightly farther out. Recognition and change live comfortably together here. That may be why the bay so often invites stillness rather than urgency. It teaches by return. Stand in one place long enough, and the evidence accumulates. Watch the tide long enough, and the scale begins to make sense. Notice the fallen stones long enough, and you start to see beaches and mudflats as the later lives of cliffs. Look at the marsh long enough, and you understand that land and sea are not separate territories here, but phases of one breathing margin. And once that understanding settles in, the whole shore becomes easier to read at dusk. The red beds beneath the dark cap are no longer just color. They are ancient river deposits exposed to a modern tide. The gravel underfoot is no longer just loose stone. It is a recent translation of cliff into shore. The brown water is no longer only opaque. It is carrying suspended memory from one part of the bay to another. The mudflat is no longer empty space when the sea withdraws. It is a temporary floor where sediment settles, burrowers work, and birds read the ground. The next flood begins already in the distance. Even if you cannot see it yet, you know what it will do. It will follow old channels first. It will lift weed from lower ledges. It will darken the notch at the cliff foot. It will surround the blocks from the last fall and begin, once again, to sort them by current and time. It will reach the marsh creeks and fill them from below. It will leave lines of wrack and new films of mud in sheltered places. And when it goes out again, for a few brief hours, the bay will expose its working surfaces and let the whole lesson be read once more. Nothing here asks to be finished. The beauty of Fundy lies in that refusal. A finished cliff would no longer be a Fundy cliff. A fixed mudflat would no longer be a Fundy mudflat. A marsh that never trapped or lost sediment would no longer belong to this tide. The bay remains itself by staying in motion. Its calm comes not from stillness, but from regularity. Its grandeur comes not from permanence, but from endless revision. Night approaches almost before you notice. The upper edges of the cliffs hold the last pale light. Below, the red sandstone turns deeper and more subdued. The basalt becomes nearly black. The water at the foot of the wall reflects less color now and more shadow. Soon the details of grain, seepage, and shell line will begin to slip from view. But that does not make the coast inactive. It only returns the lower work to darkness. If you were to remain here through the evening, listening more than looking, you would still know the bay was shaping itself. You would hear soft water at the stones, a muted shifting of pebbles where currents gather and release them, perhaps the distant, thin calling of birds over the flats, perhaps fog moving in so gently it seems less like motion than thickening air. And beneath all of that would remain the larger certainty. The cliffs are still giving way by increments. Sediment is still settling where the flow slows. Marsh edges are still holding or losing fine particles according to the tide's reach. The bay is still exchanging form between sea and land. That exchange is the real shape of the place. Not the cliff alone, not the mudflat alone, not the tide alone, The shape is in their relationship. A vertical wall becomes scattered stone. Scattered stone becomes beach. Beach gives sand and silt to the tide. The tide lays some of it down beyond the cliff. Plants catch part of what settles. Channels rework the rest. And over all of it, the moon keeps time with a patience beyond concern. So when you look once more at the dark line of basalt resting above the red face, you are not really looking at a fixed boundary. You are looking at a pause in a long transfer. The rock has not stopped becoming